Today we discuss the basics of vibration. So here, what are the vibrations, or how we can describe that vibration. So any oscillatory body, we can say that vibrations are found in that particular system or for that particular body. So any oscillatory motion we can consider as a vibration. Any oscillatory motion we can consider as a vibration. And if we look at this, so any oscillation motion in that system is we can call as a vibration. And if we consider this example as a spring and mass, then we can observe such type of the oscillation. So again, there are day-to-day life, there are so many applications where we observe vibrations. So that rail platform vibrate when that rail bogie is passing over that rail platform. So this one of the type of vibration. So in machine, due to the rotating motions of the different parts, there are certain vibrations. In car, due to the engine vibrations. Again, there are musical instruments. There are so many examples in day-to-day life we observe for the vibrations. Generally, the vibrations are unavoidable. So it has some harmful effect. It have a harmful effect of that particular vibrations. It have a harmful effect of vibrations. Again, but instead of that harmful effect of vibration, there are so many useful effects of that vibration also. So these are the we observe here as in compressors, in testing, or there are some concrete mixtures or ultrasonic cleanings, or in different massage applications. There are so many applications in which vibration is a essential one, or vibration have some desirable effect. But in general, that vibration is an undesirable one, and we try to avoid that vibration to avoid destruction of the particular system or machine. So there are again some examples: our heartbeat, lungs oscillations, eardrum vibrate, so that we can listen certain sound. So there are again sound waves. These are the some useful applications, so that we can hear or we can speak like that. So these are the day-to-day life examples. And we can model any system. In first lecture, we observe that we can model any system as a mass, spring, and damping system. So any system we can split into the mass, into these three elements: mass, stiffness, and damping. So here it represents some combination of systems. So that represent here, that mathematical modeling here represent here. So this is the vibration. So generally it is unavoidable, but in some application these are desirable. So these are the in this friend column. These are the applications where that vibrations is desirable. In this right hand side column, these applications where it is not desirable. So these are the applications where it is a desirable one and where it is an undesirable one. So in machinery also it is an undesirable one. So there are, in transportation or in different machineries, vibration is a undesirable one. It is not desirable one in any aspects. In machinery point of view. In some application, it is a desirable one. So in this vibration in healthcare, so we can plot that particular. So how we can use that vibration in this healthcare? So In ECG application, or when we plot a heartbeat on a paper by using that ECG, in that case accelerometers are placed on our chest and that measure our heartbeat vibration or heart vibration, and they plot that on a paper, and then doctor say that this is a good sign or it is a some danger. For heart diseases, we generally plot that heart vibrations on that ECG, and in that case, that vibrations are utilized to say that whether a person is a healthy or not. So again, there are some vibrations in structure also. Again, there are so many. So earthquake is another example. Earthquake is another example of vibration. So in this earthquake also, some vibratory motions. Due to the vibratory motions, some consequences we observe. So these are the some here it represents some type of that vibration. There is a static vibration, dynamic vibrations, periodic, impulse type, random type, harmonic, non-harmonic, steady state, and transient. As we move further, we go through these different topics. As we move further, we go through these different topics. As a static vibration, dynamic vibration, periodic vibration, impulse type, random type, harmonic type, non-harmonic. As we go further, we go through these different types of data vibrations. But in this slide, we observe the day-to-day life applications, which we observe in day-to-day life. We can understand vibration. So it is a periodic motion. Just we already discussed. It is a periodic motion that repeats itself after a certain interval of time. So these are the certain definitions. These are certain definitions which are used in these vibrations. It is a periodical motion. So time taken for one complete cycle. So it is a oscillator motion. There is some cyclic motion we observe. Oscillator motion or cyclic motion we observe for a particular time. So for one time required for one complete cycle is nothing but a time period. Again, simple harmonic motion. In simple harmonic motion of the particle with uniform angular velocity, trigonometric functions can be also used to represent such type of thing motion. So oscillator motion, how we can represent on a paper, or how we can represent that oscillator motion. That oscillator motion we can represent by means of the simple harmonic motion. So these are the some definitions which are used in the vibration. So amplitude is nothing but a maximum displacement of vibrating body from its mean position. So it represents that amplitude. Frequency is nothing but number of cycles per unit of time. So it is oscillator motion for unit time. How many cycles that oscillatory body completes? It nothing but a frequency, which generally represented by a omega sign. And unit is a cycle per second or hertz. So again, there are some definitions of free vibration and force vibration. So when system vibrates with its own elastic property, it is called as a free vibration. There is no external force is present. After initial excitation. There is no external force is present. So in force vibration and free vibration, excitation force is required. In free vibration and force vibration, excitation force is required. But in both cases, excitation force is required. But in free vibration, that excitation force is vanished after the initial excitation. That excitation force is vanished after initial excitation. And in force vibration, that excitation force is available for each cycle. There is no certain initial excitation, but after initial excitation also external forces exist for the further vibrations. So this is a natural frequency. So natural frequency is the frequency of pre-vibration of system, which is nothing but a natural frequency, which is generally denoted by omega with suffix n. So another one is the resonance. So when natural frequency and external frequency match with each other, that amplitude of vibration become excessive, and that amplitude is nothing but a resonance. That amplitude is nothing but a resonance. So here in this resonance, we observe a maximum displacement. We observe maximum displacement, and which is a undesirable one. It is undesirable. Here stresses are maximum, and that vibrating system may break or may fail if that resonance condition is going on. So it is a dangerous situation, as that amplitude of that vibration is a very large one. So it is a resonance. So again, in the basic definition, one more term is introduced as a damping. Damping is nothing but a resistance to the oscillatory motion. So oscillatory motion, in ideal case, that oscillatory motion is continue for infinite time. Oscillatory motion is continue for infinite time. But in actual case or in practical case, that oscillatory motion stop after a certain time. It means some element provide resistance for that oscillatory motion, so that that oscillatory motion stop after a certain time. So in every cycle of that oscillatory motion, some energy is lost in the resistance of that particular material, resistance of that particular element. So that resistance is nothing but a damping, which is available in the, or which provide in that vibration, so that that oscillatory motion stop. So this is nothing but a damping, which is a just it is a resistance offered to that oscillatory motion. Maybe it provided by means of air, oil, or by any another means. There are, again, in that damping there are different types of damping. As we go further, we go through the different types of the damping. Again, degree of freedom, there are number of independent coordinates which useful to specify a particular system, which is useful to specify a particular system motion, and that is nothing but the in degree of freedom. Single degree of freedom system, it means only one coordinate system, only one independent coordinate or only one variable is sufficient to express that particular system, like that.